Alright, you are welcome again. In this lesson, we are going to consider double integral. Okay, let's see how we can solve double integral. Let's take a look at this question. Evaluate the double integral over the indicated region. The double integral over the region R, x exponential raised to power x y dA, and then the region is -1, 2 and 0, 1. So the indicated region, if we succeed in getting the double integral of this indicated region, we are simply talking about the area of this region. Okay, so here let's go. We are going to say let this -1, 2 be the region for x, and then 0, 1 be the region for y. So we can simply take this -1 and then 2 to be the upper and the lower boundary for the integral x, and then the other one to be the lower and upper boundary for the integration y. You get it right? Good. Put it in a proper integral sign. It's going to give us the integral from the region -1 to 2. This is for x, and then the integral from the region 0 to 1. We have x exponential raised to power x y. You got it right? Then we say dy dx. We say dy dx. Is that clear? So in this place now we have the inner part of this integral and the outer part of this integral. So the inner part is with respect to y, and the outer part is with respect to x. Okay, so you can take any of them first, but let's take with respect to y first. Let's take the inner part, okay, and evaluate. So taking the inner part, you are going to say the integral of x e raised to power x y dy. We integrate this with respect to y, right? So integrating with respect to y, that means we hold every other variable constant. Is that clear? Now let's go. For us to integrate this x exponential raised to power x y dy, we are going to say let u be called x y, or let's call this x y a letter u. In this place where we have e raised to power xy. Now this xy, let us call it a letter. Which letter? U. Okay, now let's also differentiate this u with respect to y, because we are looking for the integral with respect to y, right? Good. Let's differentiate this u with respect to y. When we differentiate, we are going to have x. You get it right? We take this x as a constant. Then when you differentiate y, it's going to give you 1 times x. So here, let's make dy the subject. So making dy the subject, we're going to say that dy is equal to 1 all over x du. Why we make dy the subject is because in this place where we have x exponential raised to power xy dy, we have changed the value from y to u. So definitely we are no longer integrating with respect to y. So we change dy to another value. That's why we say dy is equal to 1 all over x du. So in the place of dy, we replace it with du because we have replaced xy with a letter u. Okay, now let's go. Let me show you. So here we're going to have the integral of x exponential. In place of xy, we replace it with u, and then in place of dy, we replace it with 1 all over x du. So here, when you say x e raised to power u times 1 all over x du, you see that x will cancel x. Is that true? Yes. We are going to be left with exponential u du. So here we have the integral of e raised to power u du. Okay, so when you integrate e raised to power u du, it's going to give you the same e raised to power u. You got it right? But you discover that x y is equal to u. You discover that u is equal to xy, right? Let's replace it here. That means we're going to have e raised to power xy. All right? So when we integrate the inner part, which is the integral of x, e raised to power xy du, the inner part. When we integrate this inner part, it gives us e raised to power xy. Hello. As we integrated with respect to y, it gives us e raised to power x. Let's bring it into this place. So that means we're going to have the outer part of this integral. We say the integral from the region -1 to 2. What we have here is exponential xy. Then we have the region 0, 1 dx. Okay, good. So here we are going to substitute for the upper boundary minus the lower boundary. Okay, so that means we're going to have the integral from -1 to 2. In place of this y, we integrated with respect to y. In place of y, we plug in the upper boundary, then we have minus the lower boundary, right? Good. When we plug in, we have e raised to power x. In place of y, we replace with 1. That means we have 1 times x, give us x. Then we have minus. We have e raised to power, we have x. In place of y, we replace with 0. That means we have 0 times x will give you 0. Here we have e raised to power 0. So the upper boundary minus the lower boundary give us e raised to power x minus e raised to power 0. And then e raised to power 0 is 1. Okay, so here we have the integral from -1 to 2, e raised to power x minus 1 in bracket dx. Okay, so here we integrate with respect to x. Okay, we integrate with respect to x. When we integrate e raised to power x, it's going to give us the same e raised to power x. And then when we integrate 1 with respect to x, it gives us x. Then we have our boundary -1 and 2. So let's plug in the upper boundary minus the lower boundary. When we plug in the upper boundary, we're going to have e raised to power 2 minus 2. Minus, when we plug in the lower boundary, we have e raised to power -1 minus, open bracket, -1. Okay, when we evaluate inside the bracket, we have -1 times -1 is going to give us +1, right? Good. Now, using this minus to open the bracket, we're going to have minus times e raised to power -1 is going to give you minus e raised to power 1. And then minus times +1 is going to give you -1. So here we're going to have e raised to power 2 minus 2 minus e raised to power -1 minus 1. So when you say -2 minus 1 is going to give you -3. Then we have e raised to power 2 minus e raised to power -1 minus 3. So as we evaluate the double integral over the region R, x, e raised to power x, y, dA, we have e raised to power 2 minus e raised to power -1 minus 3. Alright? Yes. Thank you very much for watching. Please, let's take more example. If you are yet to subscribe to our YouTube channel, please do us a favor and click the subscribe button. Make sure you turn on the notification, like, share our videos, and stay blessed.